Alright, today we're going to do indirect measurement. You're going to use proportions just like we've been doing, like we've been setting up, so you know how to do it. The thing about indirect measurement is sometimes there's things that you can't measure just because you don't have a tape measures long enough, or it's just too tall, just something that's kind of hard to measure. So we have ways of indirectly measuring, meaning we measure other things that we know are going to be proportional to the thing we want to measure, and we know how to use proportions and solve different things. So there's a technique called shadow reckoning, and so you can use the length of the shadow compared to the length of a shadow over something else that you do know how tall it is, and you can find the height of that object. Here they're giving you it's supposed to be a statue of the Korean War. And they want to know how tall it is. And it says it gives off a shadow that's 43.5 inches. And a torus standing nearby gives off a shadow that's 32 inches. And that torus is 64 inches tall. So what I can do is I can set up a ratio or a proportion and solve for the statue. And you can write 100 different ways. The easiest thing to do is just go small over large. And we're going to do the height. And then on the other side of the proportion, you're going to do the shadow. Now you want to keep those separate. You want to make sure you know which one's which. So the height, what's the height of the person, or the torus, the small? 64. What's the height of the large, or the statue? X. Okay, we don't know. What's the length of the shadow on the small or on the torus? 30. Okay. And what's the length of the shadow on the statue? 43.5. So we just cross multiply and solve, right? We've been doing that. 32x is equal to 64 times 43.5, which gives you 2784. Divide by 32, since we were timesing by 32. X is equal to 87 inches. Make sure you have your units, and there you go. Alright, here they give us a problem that talks about a bell tower, and it says this bell tower, you're going to need to figure out how tall it is, and it says it gives off a 27.6 foot shadow, and a torus standing nearby that's 6 foot tall gives off a 1.2 foot shadow. So we just use shadow reckoning proportions to solve for the height of the bell tower. So let's go small or large. Right? And again, you want to keep them to where you know what you're talking about, what units or what thing you're working with. So I do height and then I do shadow. What's the height of the person, the torus?
6 feet.
6. And the height of the bell tower?
X.
X. What's the length of the shadow for the small person?
1.2.
Okay, and what is the length of the shadow for the large or the bell tower? 27.6. Cross multiply. 1.2x is equal to 6 times 27.6, which is 165.6. And then I do what, Alan?
Divide that by 12.
Divide that by 1.2.
1.2.
Make sure you keep your decimal in there. 165.6 divided by 1.2 gives you 138. So the bell tower is 138 feet tall. Alright, sometimes you have to use a different method than shadow reckoning. Like if you want to measure this black object here, is supposed to be a pond or a lake. Right? You can't use shadows to measure distance across the lake. So instead what surveyors do, and this is actually what they do, is they set up similar triangles. They have a way of setting up triangles that are going to be similar. Okay? And they have a method of doing it, but this has already been done for us. And you know these triangles are similar because it says right here, triangle STU is similar to triangle VQU. Your job is to figure out what is X, what is the distance across the pond using the similar triangles that have been set up. So go small over large. And usually the triangle setup is going to be smaller, but it doesn't always be that way. All right? And this is just going to be the similar triangles, just like we've done before. So I'm going to do the side that's UT first. What side on triangle VQU is proportional to UT. Someone have any idea? VU?
QV.
No. QV? No. QU. Look at it here. This side, let's say it's next to the right angle. Okay, what side would be proportional to UT? QU. See how they're the same side? Okay, so QU. Alright, and then let's do the only other side of the triangle, and that's ST. What would be the corresponding side on the large triangle? QV. Okay, think about a couple things. One is they need this side, so I have to use it. If I haven't used it, I need to. And do they tell me how long VU is? So could I use that side? What side's proportional on the small one to VU? SU, right? This side. See how this is the slanting side? Okay. So, because you could think this angle is going to be equal to that one, and this angle would be equal to that one. Right? So that might help you out a little bit. But this side you can't use, so you can't use this side. Right? And this is the side you need, which goes with that side, and this side goes with that side. Now I just plug in numbers. UT is 10, QU is 16, ST is 20, and QV is X. So I cross multiply. 10x is equal to 320. Divide by 10. X must be what?
32.
X is equal to 32 meters. Make sure you have the units on there. Alright, here's your homework assignment for today.